Hello and welcome to my new video. This is essentially a follow-up to my previous one about prompting. During my prompt testing series, I found that the FLUX model may not be as strong when it comes to embedding our prompts consistently in image generation. However, it does have a surprising advantage over other models. Both of these relatively new models, Stable Diffusion 3 and FLUX, use the T5 CLIP Text Encoder model to process our text inputs. Yet, the architecture and training of the SD3 model are better optimized for text-to-image generation. Nevertheless, this difference, combined with FLUX's distinct architecture and its sheer number of parameters, 12 billion to be precise, means that FLUX excels in image-to-image processing. To see what this means for us, especially in terms of our text inputs, we first need to set up the base workflow for the FLUX model. For that, we'll need the Load Diffusion Model node, a basic guider, the K-Sampler Select node, a basic scheduler, some random noise, and a Sampler Custom Advanced. Now that we've got all of these, we need to connect them to the K-Sampler. Of course, don't forget the empty latent image. Along with the VAE Decode node, an image preview, and the VAE Loader, where we can select the appropriate FLUX VAE model. To process our prompts, we need the dual clip loader and the clip text encode node for the FLUX model. The condition from the encode node is then linked to the basic guider. In the dual clip loader, we simply select the appropriate clip model, in this case, the FLUX T5 CLIP Safe Tensor and the CLIP L Safe Tensor. With the base workflow set up, we can enter a prompt, adjust the resolution, and click Q Prompt to see if we've missed anything. Looks like we haven't, so let the fun begin. As we all know, the CLIP model is trained to process our text inputs. You might have got a brief glimpse of how the process is run behind the scenes in ComfyUI from my previous video. The T5 model is essentially an expanded version of the CLIP model, 5 times larger, and it can process more complex text inputs. One of my more amusing observations with prompts is that you always seem to get something out of the image generation process, no matter what you input. For my science fiction novel, I've developed several languages for the alien species in the story, particularly for those who use a written language. To push the language processing abilities of the models and explore their limits, I like to input a few phrases in these fictional languages. Li ele jolade oila sana siowai. Hia dos layes da shedu haleuta inatim lea. Ihalaya consenoleath gonatim. The language models try to process these inputs by matching them to known forms, linguistic structures, and meanings. The results are quite interesting. The Pixar models, for example, create at least imaginative images from these prompts. Here's an attempt using FLUX. As you can see, The only output that even remotely fits the genre has the description science fiction art before the phrase. Otherwise, the outputs are quite random. What's also surprising is that only the Euler sampler managed to process the prompt at all. And even more surprising is that the DDIM model completely failed in this task. Eshe sonuai deshnei la heshna dai notisetu, gefia yeloria suna sentalea. Iosh lagotai e fateia gotsonu dataleria yolores? Trashleuhot dad galleana suth. Eloria tretailri oniath defiriash sol senoleath. Elorion sonaith i haleakon system des sieben Welten. Elea sen. Dad salayath sat salea. Now, let's get to the cool surprises. For this, we need to swap out the empty latent image node for an image loader. To push the boundaries, and because I've always wanted to try this, I created a few prompts with detailed descriptions of different art styles, like abstract art or comic book style art, and so on. As always, you can watch the entire testing series in the uncut version of this video. For the reference image, I used MRI scans of my brain. If you try this with SDXL models, you can pretty much expect failure. But here, it worked almost brilliantly with some surprisingly cool results. The DDIM sampler, paired with the DDIM uniform scheduler, worked almost every time. Through the guidance setting in the CLIP Text Encode node, you can increase the prompt's influence. The next surprise is that we didn't even need to lower the denoise value in the basic scheduler to let the input image have its effect. If you do lower it to 0.7, the model uses almost the entire input image. The prompt execution, meaning the transfer of the art style, works astonishingly well. However, you need to keep the prompt relatively short and precise. Overly elaborate prompts don't necessarily yield better results. At least I had expected the T5 CLIP model and FLUX to work better together here. The second cool surprise is that we can use the seeds in this model almost like IP adapter embeddings. I also used some text from my novel here. The Elorian species have developed an art style called bacteria and fungus painting. In this process, bacteria and fungi, along with their spores and fibers, are genetically altered and cultivated to grow in specific colors, forms, and movements on canvases as intended by the artist. I created a few prompts based on this and fed them into FLUX. After a few passes, you just need to input the appropriate seed into the random noise node, set it to fixed, and the input images will take on this artistic style. That's it for this video. Thanks for watching. If you found it helpful and/or interesting, I'd appreciate a like and subscribe. And don't forget, have a great day.